Welcome back, geometers. Okay, in this, this practice test is going to be pretty similar to your Chapter 1 test. In the future, what I will very specifically aim to do is make the team test a step harder. Not to hurt you guys or anything, but if you can collaboratively solve harder problems when you're doing them independently later, it's going to seem a little easier. Okay, so here we go. Our first problem, we're going to see how long it takes when we talk through everything. I want to find the measure of segment GM right here and the value of R for this problem. Is there anything just based on what we see that you would like me to add to this picture? The whole length, says Lily. What is this whole length? 25. Why on earth would we add that the entire length is 25?
Because we see in the question it says if DM equals 25.
Hey, I give you that information. First of all, love it. Okay, if I want to find R, I need an expression or an equation that allows me to solve for it. Is there any things that I could add up that I know what they add up to?
The DG and GM.
Segment addition says I can add these, and if I add these up, they better be 25. Everybody agree with that? Okay, let's write that expression. I'm gonna just plug and chug. R plus 3 plus 4R minus 28 better add up to what? 25. Okay, it is on you guys. Vincent, where's yours? Golly, I forgot you twice. It's only because of where I'm looking on the screen. I promise that. How many more times do you think I can forget today, Vincent?
Maybe another one.
Ooh, I at least one more. Easy. Okay. I should probably also take attendance for every hour. All right, V-Dog, I'm gonna make you do me a favor, okay? We're gonna do each other a favor. I'm gonna print your test, and you're gonna go pick it up. It'll be in the office in front of Miss Katie, like in the big office there. If you want to go now, you're gonna miss one problem, or we can all awkwardly wait here for like 2 minutes while it prints. Thoughts?
What do y'all think? Yeah, let's awkwardly wait.
Okay, we're gonna get really awkward though, just so you know. All right, even more so because I'm trying to find it and I can't.
Did I?
All right, Vincent, you can go now. You're gonna beat it. It'll come, like you're gonna beat it down to the printer. You
This
will
Saturday.
see it printing here in a
Get
minute,
enough
okay?
plate and head up to Cash's mom's house and watch him with Derek.
I could watch them from my house.
Yeah.
My house will the whole park.
Yeah, Cash's mom's house has like a good view of the dock and he made like chairs and stuff, so I might just grab the plate and just head up there and we'll watch from.
You could hold the ball. You have like by a house. It's
Come
a
on.
two-story.
True.
Come on.
Here we go. Continuing on, I'm going to combine like terms. And in the interest of time, here's what I'm going to suggest. I would like to not have to talk through every little part of it so we can make some of our note card together. If I write something and you go, what the heck, how did he do that? When should you interrupt me to ask that question?
Immediately.
Immediately. Don't wait 10 minutes and go, hey, remember the problem we did earlier? Like, no, don't do that. Like terms. 4R and 5R add up to, just kidding, dang it. R and 4R add up to
4.
5R. If you have $4 and I give you $1, you have how many dollars?
$5. So I
Boom.
forgot that
Cool.
one. All right.
3 minus 28 or negative 28 plus 3? Is it negative 25? And that's equal to 25, right? Okay, 2 steps in 1 right here. I'm going to add 25, and in my head, it's 50, right?
Yeah.
And then I'm going to divide both sides by 5.
Yeah.
I think I get R equals 10. Okay, are we done? No. If I know R is 10, how do I find GM?
Plug it in.
4 times 10 is 40 minus 28. I think GM is 12. Okay, where do you think the 3 points would come from if this problem shows up on the test? One for R, one for GM,
One for work.
one for work. Now, whether I write work or not, what I'm really after is, are you trying? there should not, like, when I say try, just so you guys are aware, I mean, are you trying something that's related to what we're doing? Like, if somebody gets to this problem and they say, oh yeah, duh, x or 2 plus 5 is 7, and this is the work that I see, am I going to count that as trying? Is there any reason that somebody would ever write 2 and 5 as 7 here? Your trying has to be linked to the problem somehow, okay? Like, just writing nonsense doesn't get you points, but trying the problem, like legitimately trying it, does. And that's not super clear, but I think we can probably all agree what trying looks like. All right. Angle DEN is bisected by ER, and I give you some measures of stuff. I want you to sketch this and find the value of x. So what should I start by sketching? And I'll let you guys read through it because this is the first time some of you are seeing it. What should I sketch on this? The angle. Can we sketch angle DEN? Like, I tell you it's 58 degrees. Do I expect you to get a protractor and measure a 58-degree angle? Not even a little bit. Check it out. Here's an angle. That's all I need. I do need to name the points. What point has to go right here? E. Good. Doesn't matter where these are, but I'll put them here. Okay, there's angle DEN. What do we have in angle DEN? There's, what's this thing called? It's called ER, but what is this?
Segment?
It's not a segment.
Ray.
It's a ray. Now, it does what?
Bisects.
What does that mean? Two pieces of the same size, right? Am I going to measure again, or am I just going to eyeball it?
Eyeball.
I'm going to eyeball it. It's not perfect, but that looks like ER to me. Now, as we look at this, couple things that we really want to make sure we do. First thing, this big angle, you know what it is. 58 degrees. Harder question, or not necessarily harder, but equally important. What does bisect mean? Two pieces, and they're what? They are both angles, but if I, like, it's a weird idea, and I'm going to use this word wonky. If I bisected a $100 bill, okay, this is a weird example. I'm going to use cut in half instead, but not physically cut. If we split a $50 bill into two equal pieces, each one is worth how much? Did I say 50? Yeah. 25, right? 25 and 25. If I bisect a 58-degree angle, and I'm not doing the numbers yet, but these are the same angle, equal size, right? And if the angles have the same measure, then we say that the angles are congruent. Do I have a mark for congruent? What is it?
Equals squiggly line.
So that's the equals, but what if I want to mark it on my picture? I'm not going to do this.
The arc.
The arc, and this is going to be terrible to try to erase. Oh, it worked. Okay, I would put one arc across here and one arc across here. Anything else I should add on my picture? Is right there. See what I did? Right there. Okay, cool. Now, two ways we can do this problem. I need to write an equation to solve, though. I know how I did it, but I don't know how you guys do it. Help me write an equation here. When you say set it equal to each other, are you saying x plus 6 equals 58? Is that what x plus 6 equals 58? Okay, so I disagree with you, but only for a little tiny bit. X plus 6 equals 58. If this is where we stop, you're claiming that half of this is equal to all of it. Is that ever true? So there's two ways we can do this. Carson suggests we just put a 2 in front of this and say it's 2 of them. When I did mine, I did one of them, and then I just did half of this. But they're the same concept. You have to use your parentheses if you're going to do it like this. 2 times that angle, so these are both x plus 6, better get me that big angle. How do we solve?
2x plus 12 equals 58.
You could. I'm going to do something different. Because if I do that, do you agree we're going to have to divide by 2 later to solve for x?
Yes.
Could I just divide by 2 now?
Yes.
What happens with 2 over 2?
Disappears.
Good. They turn to 1. So I'm left with x plus 6 equals 58 divided by 2?
29.
29. We're almost there. One step left. I'm going to subtract 6 from each side. And I get x equals 23. Done. Now, Notice the subtle little thing. If I ask you to solve for an angle, I expect degrees here. But if I ask you to solve for just a variable, no need for the degree. I won't count you wrong if you include it, but it's important to realize we don't need it. Cool. Questions? Yes. 3 points. Did you draw the picture? Did you get x is 23? And did you give an effort that looks like you're using the math here? Cool. Awesome. This, go ahead, Ray.
When doing a proof, what is the thing on like the right side called where you
Justification.
justification?
Yep. Okay. So for this one, I give you statements and I'm just asking identify a hypothesis and a conclusion. We're just going to use P's and Q's for stuff. But as we read this, to vote in American elections, you must be 18 years old. That is a true conditional, even though I don't use the word if and then. If you wanted this to be an if-then statement, what would you do? What would you pick as the if part? If you are 18 years old, and check it out. Instead of writing the hypothesis, we use P for the hypothesis normally, right? I'm just going to do this, P. If you are 18 years old, what do we conclude based on this information?
Vote in American elections.
You can vote in U.S. elections. That's our conclusion. What letter do we use for it? Q. If I wanted you to write the simplified form of the conditional, you could write, if you are 18 years old, then you can vote in U.S. or American elections. Or we can all just agree that we have a better way to write stuff because mathematicians are lazy, thankfully. Does this say the exact same thing, but with like a million less letters? Not literally a million, but same idea. If you want to write a sentence instead of if P then Q, I'm okay with it. Could we have gone the other way? If you voted in an American election, then you were 18 years old. That would also work, right? So in this one, it turns out it doesn't really matter what you pick for P and Q. Either would work. This question, pretty easy. On B, this is the part that I care the very most about. The if and only if. It has meaning. If and only if, or if. How do we write that? Like, which of these would you want as the hypothesis? Is it true that if you like math, then you understand the material properly? You think there's many people who like math but don't understand the material?
Yes.
Okay, well, awesome. Okay. I think that there's more of a connection in general, maybe not for everybody, but let's try it the other way. If you understand the material, and I'm like understanding good at it, I just didn't write it all, are you probably going to like math a little bit? I think that one's more believable, but I think they both are. But which, God, what's if and only if do though? What do you mean by that? Love it. It means that if you understand the math, or if you understand the material, then you like math. So we could do it like this, P and Q. But it also means that if you like math, then you probably understand the material. Ashley, you did it perfectly. You said double arrow. Boom. If and only if just means both directions. A statement or a conditional and its converse. Okay. Each one of these just 1 point. Did you identify P and Q, and did you write a conditional? Okay. Second page. I think 4 is close to the hardest problem. Can you guys plot points? Okay. I will try to make it so it's easier to see. I don't know why it looks like this on my screen, but when I go to print it, it looks like yours. I want you guys to help me plot here. I want to plot point A. So here I am at the origin. What do? Left 3, 1, 2, 3, and 1 up. If I don't specify, and if you can't see it on yours, and I will put these ticks on here with a pen so that it actually shows up. Here's point A. It's at 3, negative 3, 1. Okay. B is at 5, 7. Can we agree that I went over 5 and up 7? If I want to make this segment AB, what do I need to do between those points? Because right now I just have 2 points, but I want a segment. Yeah, just connect it with a segment, right? Holy cow, I don't have a straight line drawing tool when I'm doing it on PDF, and that came out really good. Okay, check it out. That's a point. Cool. Plot points. Easy. How about the midpoint? Ooh. I want to find the midpoint and name it M. How do you find a midpoint? So x1 plus x2, and then do what to it? So check it out. Help me out. What's x1 plus x2? What's x1? Sure. Plus? Over 2. Now, anybody in here struggle with negative 3 plus 5? I don't believe you. Somebody's going to get goofed up and say it's negative 8. It's inevitably going to happen. If you don't like negative 3 plus 5, can we just switch it around and do 5 minus 3? Yeah. 2 over 2 is what we wind up with here. And for the y's, same thing, right? 1 plus 7 divided by 2. What's 2 divided by 2? And what's 1 plus 7? 8 divided by 2. Boom, look at that. We have our midpoint. Now, there's another way to do it, but I'm going to plot it here. We could have just counted, but I want the math, right? Because if I give you like points that are really far away, I don't want you to have to draw it and count it out. What about the distance formula? Now, Ray asked about it, so I know it's on the board right here. But hypothetically, if you don't make a note card, you didn't have the distance formula, are you probably going to remember the distance formula? Realistically, probably not. Some of you might, but most people won't. But you do remember another handy theorem that we used to get this. Old Pythagoras hooked it up. He said if you square this and add it to this, you get the square of this. Okay, you could use the Pythagorean theorem if needed. I would much rather use the distance formula. Okay, the distance formula. Can everybody see it written on the middle whiteboard? On the left, near the screen. Cool. So, check it out. Let's plug and chug through that. I'm going to give you guys a head start. I'm going to close the door there so that we don't get distracted. I want you guys to try to use that formula. Find me the distance. If you're struggling, I'm going to plug into that formula. If you don't remember that formula, that's probably something I'd put on your note card. But here we go. I know it's x2 minus x1. I'm going to do 5 minus negative 3. Squared plus 7 minus 1 squared. And let's just clean it up a little bit. What's 5 minus a negative 3? 8? Good. It changes to plus. And this one is 7 minus 1 is 6 squared, right? Okay. You may show more or less work than this. Probably less than I'm doing. Do you guys know what the square root is? Or sorry, 8 squared is?
64.
Plus,
36.
and what do those add up to? Does 100 have a nice square root?
Yes.
What is it? Look at that, we're done. Now, in past years, I've eased up a little bit. In past years, I used to count you wrong if you gave me a distance without some sort of unit. If it's not specified, you should always include units on distances, but I won't count you points off. Okay. Now we're all going to work together. And I'm going to have a suggestion because if we don't do the following, this proof looks ugly. Cool. Any questions about anything here? All right. We're going to write a proof together. And I'll do it up here. That's fine. Here's our proof. Now, we need to wind up showing that angle ABD, and I'm just going to look at it here, ABD, this big angle here, is congruent to this one. That's the goal. Here's what I'm going to suggest. On a test, if we wind up writing measure of angle CBD and like write a bunch of letters, do you think it's easy to get goofed up on what you're writing? So here's what I'm going to do. I'm going to label these angles with numbers so they're easier to write and easier to think about. Anybody opposed to doing that? So I don't really care where we start. I'll start right here for no particular reason. Angle 1, 2, 3, 4, and 5. Whether we use all of them or not, I don't know. We'll see. But I do recommend on a test or quiz, if you label them here, I will go with the labels that you use. If you don't label anything and use angle 1 and angle 2, I won't give you points because I won't know what you're doing. Okay. Sorry about the mistake on this one. For those of you that were in class yesterday, my bad. I have a lot of apologies to do to the bigger fifth hour class as well. But, okay, let's run through it. The hardest part of a proof is right now. Now, there's two ways we can approach it. We can either try to think out the logic behind it and then write the proof, which some of you might prefer. Or you look at it and go, I have no idea what to do. I don't even know how to think about what I'm trying to do. And you're not going to give up, even though that's a natural step. There is always something that can be done. Now, if you don't have the logic for the whole proof, that's okay. We're going to build it together. All I know is that I start here, this is my given, my if statement, and I need to wind up here at the very end. That's the goal. I cannot ever write that these are equal until the very end, because then we would be trying to assume what we're trying to prove what we're trying, like it just doesn't work. We're circling. Okay, here's my first piece of advice. If you're ever struggling with a proof, I will always refer to this as unpack the given information. And really I call it unpack the givens. What does this mean? The fact that BD bisects this. So what?
Like are 2 equal. 2 and 3 are congruent.
Ray says that if this ray bisects this angle, then 2 and 3 are the same size. Do you guys agree with that? Because it's what it means to bisect, right? So with the numbers, this is going to look much nicer. I think then right away on line B, we can say angle 2 is congruent to angle 3. Now, beyond that, I don't only need the statement, but I need to know why. How did we know that that was true? So just because two angles share the same side won't do it. What was the word that we used to get to the fact that they were congruent here, though? Bisect. So we took an angle and we bisected it. I'm okay with just saying it's an angle bisector. You can write the word out if you want. That is my shorthand for bisector. Okay, other big one. Homework problems, you probably didn't draw any proof because it's in your book and you can draw on it. If I give you a picture or if you draw your own, the second I write something that I could mark, you should mark it on your picture. I'm going to put one arc across 2 and one arc across 3 so I don't forget this. Okay, have I lost anybody yet? Now, as I'm starting to look at it, I'm starting to see that I need this angle to be the same as this one. That's what I'm trying to show. And if I look at these angles, I'm going to step back just for a minute. If I asked you, how do you form this big angle? Can you guys tell me?
Splitting 5.
1 and 2.
ABD is just angle 1 plus angle 2. Do you guys agree with that? Now, as I look at my proof, I realize I don't have angle ABD in here anywhere, so I need a way to write ABD. And we just found a way to do it. I'm going to write ABD and FBD. These are going to be the only letters that I use in my proof, and we're going to use that idea that we just saw. If I have the measure of angle ABD, alpha, Bravo, delta, I know that that is found by adding up 2 angles. What are those 2 angles that make A to B to D? Measure of angle 1 plus the measure of angle 2. Why am I allowed to write that? It is a good one. If you don't know why I can write it, do you get a free pass? Did we talk about the free pass in here?
Yes.
It's freaking magic if you don't know it, but we are going to know it because I'm going to give it to you. At the beginning, we didn't write it. Anybody recall what I said when said, oh yeah, we can put these 2 smaller pieces together to get the big one? Segment addition. Did we just take 2 smaller pieces to add them up to get the bigger one? But they weren't segments.
Or angles.
This is angle addition. It is a postulate. I don't care that if you write angle addition postulate. I'm okay with just angle addition. Notice, I know that I had to do this because I needed to get ABD into my proof. I now have ABD in my proof. What else do I need in my proof, though? Not only ABD. Is there a way using angle addition that we can get FBD in the proof as well?
Yes.
How?
Same method.
Okay, so I know, measure of angle 3 plus a measure of angle 4?
Yes.
Okay. And notice, I didn't call this C because I'm going to use the same angle addition. If you want to, do I care if you do this? I'm going to undo it here in a second. But do I care if you do this?
No.
No, it's completely fine. I think it's a waste of time. But if that makes, like if you've already committed, rather than erasing, I don't mind if you do it. All right. Again, I just want to stress, I'm trying to wind up here, and I chose these because I needed a way to get these in. Now, again, we're going to look at it a little bit more. If I add angle 2 to something, based on my picture, do you agree it's the same thing as adding angle 3 for all intents and purposes? Because they're the same angle, right? Man, that pesky 1 and 4 are just ruining my whole logic. Anybody know anything about these angles? Because I've already written 1 and 4. Anything true about these two?
They're the same.
Why are they the same?
Adjacent.
They're not adjacent.
They're vertical or whatever.
They're vertical. Like, and I think that you have the right idea, and I think you just misspoke. But the language does matter with the justification. So here we go. Step D. I think that I agree that angle 1 is congruent to angle 4. The second I write it, again, I'm going to mark it. These get 2. And that one's ugly, so I'll do it bigger. So 1, 2, and 1, 2. How do we know that? Vertical, and I'm just going to use vert angles. I am totally fine with you guys shorthanding stuff, so long as you write it in a way that anybody who's at least familiar with this stuff, me especially, can pick it up and go, oh, that's what you did. I just need to be able to understand what you're doing. Use cave person language all the time if you want. Now, we are almost there. And one thing you're not seeing me do is the really tedious part of proving stuff. If we wanted to be crazy hardcore, and we'll get there, but we're going to ease into it. If these two are congruent, normally my very next line would be the measure of angle 2 equals the measure of angle 3. Because we really don't add or subtract or do any stuff like that until you have the measures of the angles. But we all know that this means that the measures are equal. We're not writing it yet. We will eventually formalize it. Okay. Is anybody's proof sense tingling at this point? Okay. This is not formal, but this is just thinking out a little bit. I need to show that this big angle is the same as this big angle, right? And here's the silly logic and the language that I've used. With the marks that I will claim are super duper important whether you're aware of it or not. I claim that this big angle is 2 arc plus 1. And I need to show that it's the same as 2 arc plus 1. Is that the same? Double arc plus single and double arc plus single, they better match, right? Like I can tell they're the same already. We just need to formalize that. Here's how we're going to do it. I need to be able to substitute something in here or here so that I can write these are equal to each other. So let's use a little bit of substitution. Now, there's not a right answer here. It's just whichever one. This shows up first, so I'm going to write it first, only because of that. We could have written a measure of angle FBD here instead, Foxtrot, Bravo, Delta. But let's zoom in. We're always going to reference back to stuff that we've written. We have to use stuff that we've justified and have a reason to say when we're showing our proof. Instead of ABD being angle 1 plus angle 2, could I replace angle 1 with anything else based on what we've written here? Angle 1 is the same as something else. They're the same, right? So I'm going to substitute. Instead of angle 1, I'm going to write angle 4. The measure of angle 4. Gosh, what about instead of... Why did I erase 4? Weird. Super strange. What about instead of angle 2? 3? And I'm allowed to do this because I'm substituting. Everybody agree with that still?
Yes.
Here's our very last. We're going to do 2 steps in 1 just to save a little bit of time. If only somewhere in our proof we knew exactly what we got when we took measure of angle 4 plus a measure of angle 3. Oh my gosh, it's right here, 2 lines above. This expression is exactly this, right? So I'm going to do 2 things. Because I need to wind up as being congruent, I'm skipping a step. I'm going to combine it. If we're doing it really, truly formal, we would have the measure of ABD equals the measure of FBD. And then if the measures are equal, the angles are congruent. Instead of making that 2 steps, I'm just going to do it in 1. At this point, and it really is just another substitution, so I'm going to erase my justification. At this point, 1 more substitution and the definition of congruent, and we've got it. I can conclude that ABD is congruent because they're equal, is what we're really doing, to which other angle? What am I substituting in for this again? FBD. And I'm going to say substitution. And if you just called it substitution, I'd let it slide here because the formal part of it just is tedious. We'll get there, I promise. I would say it's substituted and we use the definition of congruent. Is this where we're supposed to end up at? For sure. How do I indicate I'm done?
Squared.
That's a good point. Quadrat demonstrandum. Or this symbol. Everybody's going to use the square, I assume. Sweet. Okay. The proofs. They take practice. Anybody look at that and go, oh my God, I'm never going to be able to do this. I hate this class. Fair. I hope you don't really hate the class. But some of you might feel like you're never going to be able to write a good proof. You might feel that way all year. I can't promise. How many points is every proof that I ever give you worth? 2. 1 for do you try it, and 1 for did you get it right. If you guys weren't, oh, go ahead.
Is it going to keep expanding?
What do you mean?
Like, proof, is it going to keep expanding, like, how we supposed to?
Not really. We'll get a little bit more formal with the moving between congruent and measure stuff. Like, we'll clean that up as we go. But the same basic idea is the same basic idea all year. We just get more theorems and a bigger list of things that we could choose to justify from. Because right now we can only use theorems or definitions, and we only have like a few definitions and a few theorems. But we're going to get, like, throughout the year, probably 150 theorems. And each chapter will have its own little set that you would use to prove stuff like that. You're not going to have to remember 150 theorems all the time. Okay. Last problem here. I ask us to find x. What kind of angle pair do we have here? And if they're vertical, what do we know about the measures? So do you guys agree that 2x plus 32 right off the bat is really and truly just equal to 3x minus 5? Okay, I'll subtract 2x from both sides of my equal sign. We get x minus 5 equals 32. I'll add 5. And we get x equals 37. And we're done. Okay. For those of you that just worked along with it, you're kind of at a disadvantage, not for the stuff, but you probably feel super duper confident about most of the stuff we just did. Remember, math always feels easier if somebody else is doing it. Like, if you guys understand it, that's a good first step. But just because you understood everything that I did and it seemed easy while I was doing it, doesn't mean that you shouldn't study this evening. Cool. If this had been a formal exam, how would it have gone? Like, roughly, do you guys think?
Pretty bad.
Pretty bad? Pretty good? Pretty mid? Cool. We're all over the place. That's what I would expect. Okay. Did I ever give you guys note cards? Half of you. For every test this year, you guys get note cards. Now, in geometry, you get, to begin with, both sides of these bad boys. So, Andrew, you can have another one. Did I ask you a question on this practice test, like every single thing that we covered in this chapter? No. Now, I will try very hard to make them match a lot. Like they're pretty much going to match. Very, very similar look. But there are a couple things that I want you to make sure that you're aware that we didn't hit here. We used all the logic stuff. We talked about conditional statements here. Did I ever ask you about the law of attachment or syllogism? No. Do you think it's fair that maybe that could show up on the test, even though it wasn't on the practice test? Yes. I'll tell you right now, the law of syllogism and the law of attachment is on your test. Which means, if you don't know what those words mean, here we are. Okay. For studying for this. Everybody studies math a different way. And I think there's probably only a few. Some of you probably don't study for math tests. And I get it. Not everybody has time for everything all the time. Some of you, I assume, study by reading over and looking over your notes, right? Does that anybody study math just by looking back at stuff you've done? Okay, so it's part of it. I would agree. Like, you should look over your notes. Like, we spend a lot of time doing them for a purpose. But remember, seeing something done and feeling like it's easy is very different than trying to do something and it's seeing that it's easy. So you should look over your notes, but additionally, you should probably work some examples, right? Okay. In your textbook, at the end of every single chapter, Do you guys have textbooks today? Okay. I'm going to open up my textbook here, and you're going to have to awkwardly wait for a minute. Oh, dang it. I thought it was going to give it to me. Okay. At the end of each section and at the end of each chapter, there's like a whole summary thing. Your notes would be, I think, nicer place to see it because it won't hit everything in here, but I will show you if I were to study at home, because I'm only going to be able to start the note card with you. Let me go to your edition. All right. As we're looking through, I'll get this open in a minute. It's at the end of topic 1. As we're going through stuff, we only have a very brief amount of time to do this together, but I think we can hit a few main ideas. I want to stress over and over for like the millionth time. Everybody's note card probably going to be different unless you all copy each other's, which you're allowed to, but that kind of defeats the purpose of making a note card. When we're looking at stuff, what I would recommend you do anytime you're working on a note card. Why can't I make that disappear? There it is. Okay. When we're working on a note card, I would just go through my notes in the book. In 1.1, we talked about some basic naming. How do we do that stuff? Do you guys know how to name a line and a segment, an array, and all that stuff? If you know the notation, do you need to write it down? No. If you don't know the notation, should you write it down? Okay. So I'm not going to write down all the notation stuff. I'll tell you, remember the first quiz when I said use the appropriate notation to write this? I don't have a question like that on the test. Instead, what I do is I just say, find AB. And if you don't know what AB means, then you're getting burned. I don't have to ask a formal question about it. Like, your understanding of the notation is going to tell you what to do. Okay, so this is easier than getting the online book. For now, anyway. Okay. At the end of each section, and I'm in topic 1, so I'm just going to show a brief example. At the end of topic 1, so section 7, the very last page in your book, it looks like this. And it says concept summary. This is at the end of 1.7, for example. Every section has this. And it says, hey, in general, we talked about proofs, and here's a basic idea, and they give an example of a proof. Every section has this with the specific stuff. So if we go back to 1.6 or 1.5 and I go to the end of it, oh, yep, here's this stuff because we just spoke about it. Okay, concept summary. In 1.6, there were 2 main ideas. We looked at the law of detachment and the law of syllogism. Going through your text and finding these pages, this is a good idea for like the main things on your note card. If you don't know the law of detachment, I would write it down. If you don't know the law of syllogism, you don't have to have this wordy version. I prefer this notation personally. Okay. Rather than, like, we only have 2 minutes and it doesn't really make sense to do it. The other option, and I want you guys to make a note card. I won't grade it, but I'll tell you I don't have to, because if you don't make a note card, your test is probably going to go pretty poorly and you're going to get the punishment for it just naturally. The other place that I would encourage you to look is at the end of the actual topic. So at the very end of topic 1. So very end, here I am. You guys will find this page. And this is on page 64 of your text if you want to write it down. The topic review. Here's all the vocab that we use this topic, or this chapter. Okay, chapter 1. Measuring segments and angles. Angle addition, segment addition. Topic 2. It says, hey, you can construct. I'm not going to make you do constructions on the test, just so you know. This page at the end of your chapter, here's midpoint and distance. This is where I would start. You can put examples on your note card. Anything that you want that you've written by hand. Okay, Carson, did you give me my pencil back?
Yeah.
Okay, cool. Awesome. Good to see you guys. We are taking the test tomorrow in class. Lily, you're doing it on Monday when you get back for this one.
Is there any way you can keep this for me so it doesn't get lost in there? Just too small. It's probably fade away.
Yes. So, Ray, I'm going to make you see where I put it. Thank you, guys. Appreciate you. Glad you know the stuff. Lily, I'll see you. Yes. Swim well. Swim hard. Have fun. Okay, Ray, I'm going to stick this right here.
Okay. You know, it's funny you are playing Minecraft because I beat the Ender Dragon last night.
And finally, out of like, somebody told me the other day they don't have a house and they just wander around all the time. I can't imagine. I spent so much time making my house.
There's a lot of different kinds of people.
Yeah, like that. The architect and design part of it is fun for me. Like I don't really care about making dye or changing color on clothes. I just have a sweet floor plan. Yes.
I forgot to grab one.
You're good. Did you get a picture of what I had done with 6 Tower? Do you want a
Yeah.
picture? You did?
Yeah.
Okay. Cool.